Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe. This is the Advent of Cyber 2024 event. This is Advent of Cyber Day 7, detecting malicious behavior in AWS. As you can see, I have already started up the VM for this room because I don't know how long these VMs usually take to start up. But it says Task 13, AWS Log Analysis, Day 7. Oh no, I'm speaking in CloudTrail. Now, hopefully, you all have an awesome day today and ready to learn something. Let's go ahead and dive into it. The story. As Socmus approached, so did the need to provide those without with something to read. Care for Wares tried, they made it their mission. A gift for all wares, a Socmus tradition. Although they had some, they still needed more. To pick up some books, they'd head to the store. The town's favorite books would no doubt make them jolly. They ticked off the list as they filled up the trolley. With the last book ticked off, the shopping was done. When asked for their card, the ware handed them one. I'm sorry, he said, as the shop clerk reclined. I can't sell you these books as your card has declined. The ware put them back as they walked in confusion. How could this be an attack and intrusion? And when they logged on, the ware got a scare to find the donations. They just weren't there. Sounds like they got owned by somebody. So there's all the books. Payment declined. Monitoring in an AWS environment. Careforware's infrastructure runs in the cloud, so they chose AWS as their cloud service provider, CSP. Instead of their workloads running on physical machines on premise, they run on virtualized instances in the cloud. These instances are in AWS called EC2 instances. Amazon Elastic Compute Cloud. Now, AWS stands for Amazon Web Services, by the way. A few members of the Wareville SOC aren't used to log analysis on the cloud, and with a change of environment comes a change of tools and services needed to perform their duties. Their duties this time are to help care for wares, figure out what has happened to the charity's funds. To do so, they need to learn about an AWS service called CloudWatch. CloudWatch. AWS CloudWatch is a monitoring and observability platform that gives us greater insight into our AWS environment by monitoring applications at multiple levels. CloudWatch provides functionalities such as the monitoring of system and application metrics and the configuration of alarms on those metrics for the purposes of today's investigation. Though we want to focus specifically on CloudWatch logs, running an application in a cloud environment can mean leveraging lots of different services. Examples: a service running the application, a service running functions triggered by the application, a service running the application backend, etc. This translates to logs being generated from lots of different sources. CloudWatch logs make it easy for users to access, monitor, and store the logs from all these various sources. A CloudWatch agent must be installed on the appropriate instance for application and system metrics to be captured. A key feature of CloudWatch logs that we that will help the Wareville SOC squad and us make sense of what happened in their environment is the ability to query application logs using their filter patterns. Here are some CloudWatch terms you should know before going further. Log events. A log event is a single log entry recording an application event. These will be timestamped and packaged with log messages and metadata. Log streams. Log streams are a collection of log events from a single source. Log groups. Log groups are a collection of log streams. Log streams are collected into a log group when logically it makes sense. For example, if the same service is run across multiple hosts. CloudTrail. CloudWatch can track infrastructure and application performance, but what if we wanted to monitor actions in your AWS environment? These would be tracked using another service called AWS CloudTrail. Actions can be those taken by a user, a role granted to a user giving them certain permissions, or an AWS service and are recorded as events in AWS CloudTrail. Essentially, an action the user takes via the management console or AWS CLI, which is command line interface, or service will be captured and stored. Some features of CloudTrail include the following here. Always on. CloudTrail is enabled by default for all users, JSON formatted. All events captured by CloudTrail will be in CloudTrail JSON format. That's awesome. Event history. When users access CloudTrail, they will see an option, event history. Event history is a record of the actions that have taken place in the last 90 days. These records are queryable and can be filtered on attributes such as resource type. Trails. The above mentioned event history can be thought of as the default trail included out of box. However, users can define custom trails to capture specific actions, which is useful if you have bespoke monitoring scenarios you want to capture and store beyond the 90-day event history retention period. Deliverable. As mentioned, CloudWatch can be used as a single access point for logs generated from various sources. CloudTrail is no different and has an optional feature enabling CloudTrail logs to be delivered to CloudWatch. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. As mentioned, CloudTrail helps capture and record actions taken. These actions could be interactions with any number of AWS services. For example, services like S3, Amazon Simple Storage Service used for object storage, and IAM, Amazon's Identity and Access Management Service, can be used to secure access to your AWS environment with the creation of identities and the assigning of access permissions to those identities. It says we'll have actions taken within their service recorded. These recorded events can be very helpful when performing an investigation. Intro to JQ. What is JQ? Earlier, it was mentioned that CloudTrail logs were JSON formatted. When ingested in large volumes, this machine readable format can be tricky to extract meaning from. Um, yeah, can be tricky to extract anything meaningful from, I guess, especially if the context of the log analysis. The need then arises for something to help us transform and filter that JSON data into meaningful data we can understand and use to gain security insights. That's exactly what JQ is and does. Similar to command line tools like sed, awk, and grep, JQ is lightweight and flexible command line processor that can be used on JSON. How can it be used? Now let's take a look at how we use JQ to transform and filter JSON data. The wheres being the wheres, they stored their shopping list from the trip to the bookstore in JSON format. Let's take a look at that. So you got book title, where's Wally, genre, children, page count 20. You can see the rest there. Charlotte's Web, crawler, Charlie in the 8-bit factory, the princess in the PCAP, the lion, the glitch in the wardrobe. That's awesome play on words for actual movies out there and books too, apparently. But let's see. JQ takes two inputs: the filter you want to use, followed by the input file. We start our JQ filter with a dot, which just tells JQ we are accessing the current input. From here, we want to access the array of values stored in our JSON with the open and close brackets, making our filter a dot and then open and close brackets. For example, let's run the following command: JQ, and then inside of single quotes, dot, open and close brackets, book underscore list dot JSON. So let's go ahead and open a terminal and do that. And of course, we're going to make this bigger to make it easier for you all to read. So we want to zoom in. Okay, it looks good. Okay. Now, where exactly? I'm trying to figure out where exactly we're supposed to run this. Maybe it'll tell us later on, I guess. But yeah, it says there's can I open this file because no such file directory. But okay, let's continue on. The command above will result in this output. I assume that this doesn't exist, but who knows? The command above would result in this output, which is this JSON format here. Book title, where's Wally, genre, children, page count 20. You can see the rest here. Once we've accessed the array, we can grab elements from that array by going one step deeper. For example, we could run this command here, which is this here. Okay, it looks like they're piping it into book underscore title. If we wanted to review all the book titles contained within the JSON file, this would return a nicely formatted output like the following here. All right. There's a lot nicer to look at, isn't it? It gives you an idea of what JQ is and what it does. Of course, JQ can filter and transform JSON data in many additional ways. In our upcoming investigation, we'll see the tool in action, the peculiar case of Care4Ware's dry funds. Now that we have refreshed our knowledge of AWS, CloudTrail, and JQ alongside McSkitty, let's investigate the peculiar case of Care4Ware's dry funds. The responsible where for Care4Ware's charity drive gave us the following info regarding this incident. We sent out a link on the 28th of November to everyone in our network that points to a flyer with the details of our charity. The details include the account number to receive donations. We received many donations the first day after sending out the link, but there were none from the second day on. I talked to multiple people who claimed to have donated a respectable sum. One showed his transaction and noticed the account number was wrong. I checked the link and it was still the same. I opened the link and the digital flyer was the same except for the account number. McSkitty recalls putting the digital flyer Wareville bank account qr.png in an Amazon AWS S3 bucket named Wareville Care4Wares. Let's assist McSkitty and start by finding out more about that link. Before that, let's first review the information that we currently have to start the investigation. The day after the link was sent out, several donations were received. Since the second day on or after sending the link, no more donations have been received. A donator has shown proof of his transaction. It was made 3 days after he received the link. The account number in the transaction was not correct. McSkitty put the digital flyer in the AWS S3 object name Wareville bank account qr.png under the bucket Wareville Care4Wares. The link was not or has not been altered. Okay, connection details basically just telling you need to start this VM here, which you've already done. Okay, and this is what you need for today. Do I need to start the VM? Yes. Is there split screen available? Yes. All right, so we're good to go here. Glitch did it. Let's examine the CloudTrail logs. Yeah, related to the Wareville Care4Wares S3 bucket. For a quick example, a typical S3 log looks like this. All right, so looks pretty straightforward. You have the event version, user identity type, principal ID, ARN, account ID, access key ID, username, event time, event source, event name, AWS region, source IP address, user agent, and you can see the rest here. So be sure to go through and look at what's going on here in this information. All right, we're going to continue on. It might be overwhelming to see the sheer amount of information in one event, but there are some elements that we can focus on for our investigation. All right, you got field over here and description over here. You got user identity, details of the user account that acted on an object, event time, when did the action occur, event type, what type of event occurred, examples, AWS API call or AWS console sign-in, AWS service event, event source, from what service was the event logged, you got event name, what specified action occurred, or sorry, what specific action occurred, list objects, get bucket object, source IP address, from what IP did the action happen, user agent, what user agent was used to perform the action, examples are Firefox, AWS CLI, request parameters, what parameters were involved in the action, example bucket name. By using the guide above, we can read the example log entry as follows. The IAM user where collector listed all objects, list objects event of the S3 bucket, named AOC CloudTrail Wareville. The IP address from which this request originated was 34.247.218.56. The user agent indicates that the request was made using the AWS SDK tool for Go. Now that we know where to look, let's use JQ to filter the log for events related to Wareville bank account qr.png S3 object. The goal is to use the same elements to filter the log file using the JQ and format the results into a table to make it more readable. According to McSkitty, the logs are stored in the following this directory called Wareville_logs. To start, click the terminal icon on the desktop, enter the commands below, which we already have the terminal opened. So let's go ahead and do that. Let's go ahead and clear all this stuff out and paste this in. Okay, now we're in the correct directory. ls to list everything in here. You got CloudTrail log.json and RDS log. And let's see here. With the commands above, we initially changed our directory, our current directory, to the directory McSkitty mentioned via the cd command, which is change directory. And we listed the directory's contents using the ls command. As you can see, two files are inside, but we will focus first on the CloudTrail_log.json for this investigation. Now let's start investigating the CloudTrail logs by executing the command below. So let's go ahead and do that. So we got JQ-R, and then it's piping it into the rest here. So I'm just going to copy and paste everything over. Okay, wow, okay. There we go. Let me go ahead and scroll up here. All right. Let's do a quick breakdown of the command executed. All right, so you have the command over here and description. The command for this one here says JQ-R, and then inside of single quotes, filter CloudTrail_log.json. Says the dot or -R flag tells JQ to output the result in raw of JSON. Note that the filter section is enclosed with, let's see. Okay, let's make this bigger. I'm not sure if this is getting cut off or what. Results in raw format instead of JSON. Note that the filter section is enclosed with single quotes. The last part of the command accepts the input file, which is CloudTrail_log.json. .records, then open and close brackets, instructs JQ to parse the events in records containers elements. The records field is the top element in the JSON format, CloudTrail log. And then they're piping it into select inside of these open and close parentheses dot event source equal to inside double quotes s3.aws or Amazon AWS.com and dot request parameters dot bucket name equal to inside of double quotes Wareville dash care for wares. Uses the previous command's output and filters it on the event source and request parameters dot bucket name keys. The value s3.aw or Amazon AWS.com is used to filter events related to Amazon AWS S3 service, and the value Wareville dash care for wares is used to filter events related to the target S3 bucket. As you can see in the command output, we are able to trim down the results since all the entries are from S3. However, it is still a bit overwhelming since all the fields are included in the output. Now let's refine the output by selecting the significant fields. Execute the following command below. So let's go ahead and copy and paste this over. Okay, and then let's go ahead and clear this stuff out. All right, now let's see here. Now this is a lot cleaner. As you can see, we have appended another pipe after our previous filter. Let's discuss it quickly. All right, so here's the command over here, and then there's description. All right, the first one here says the piped filter uses the previous command's output and formats it to only include the defined keys such as .event time, .event name, and .user identity, .username. The defined keys are enclosed with the square brackets to process and create an array with the specified fields from each record. Note that the string in front of these um, it says sorry, double quotes here. N a is included purely for formatting reasons. This means that if the defined key does not have value, it will display the NA instead. As you can see in the results, we could focus on the notable items, but our initial goal is to render the output in a table to make it easy to digest. Let's upgrade our command with the additional parameters here. So let's go ahead and do that. Copy and paste. Okay, there we go. Now it looks like an actual like log file you would see in something. You may observe that we have added the following to our command. So you have the command on the left again and description on the right. All right. It says the new command prepends a column header row and is defined using square brackets since it is an array that corresponds to the selected fields. Note that a comma is used before the select filter to combine with those of the select filter results we previously used. Okay, and this here says sets each array element the output processed after the filters as a line of tab separated values. And the last one here says it takes the output of JQ command, now resulting in tab separated values, and verifies its results by processing all tabs and aligning the columns. Note, our crafted command lets us summarize S3 activities from a CloudTrail log. Now that we have crafted a JQ query that provides a well-refined output, let's look at the results and observe the events based on the columns. We can answer the following questions to build our assumptions. How long or how many log entries are related to the Whereville dash care for where's bucket? Which user initiated most of these log entries? Which actions did the user perform based on the event field or event name field? Where were there any specific files edited? What is the timestamp of the log entries? What is the source IP address related to these log entries? Looking at the results, 5 logged events seem related to the um, where Whereville care for where's bucket, and also or almost all are related to the user glitch aside from listing the objects inside the bucket list object event. The most notable detail is that the user glitch uploaded the file Whereville bank account qr.png on November 28th. This seems to coincide with the information we received about no donations being made 2 days after the link was sent out. So if we take a look over here, we can see what they're talking about. All right, so event time 11:28, event name, list objects, username, glitch, bucket names here. You got the key, nothing in there, and you have the source IP of where all this activity came from. All right, so you can see everything here, and then you can see the activity down here for bank details, Whereville bank account qr.png. So glitch was in here messing around with stuff apparently. And let's flip back over. It says McSkitty is sure that there was no user glitch in the system before. There's no one in the city hall with that name either. The only other person that McSkitty knows with that name is the hacker who keeps to himself. McSkitty suggests that we look into this anomalous user. McSkitty fooled us. McSkitty wants to know what this anomalous user account has been used for, when it was created, and who created it. Enter the command below to see all the events related to the anomalous user. We can focus our analysis on the following questions. What event types are included in these log entries? What is the timestamp of these log entries? What is the IPs, or which IPs are included in these log entries? What tool/OS was used in these log entries? All right, so once again, we're going to copy and paste this stuff over like so. Let's go ahead and clear all this stuff out. Okay, there we go. Now it has a lot more information in here. Same uh, type of format it looks like. So we have event time, event source, event name, username, and source IP. You can see what happened here. It says the results show that the user glitch mostly targeted the S3 bucket. The notable event is the console login entry, which tells us that the account was used to access the AWS management console using a browser. So flip back over here, we can see that information. Yeah, we can see it right here. So it even says sign in dot Amazon or yeah, Amazon, AWS, etc., etc. And let's continue on. We still need information about which tool and OS were used in the request. Let's view the user agent value related to these events using the following command. So let's go ahead and do that. Copy and paste the stuff over. Clear all this out. All right. Whoa. All right. But anyway, we can see the user agent right here. Okay. Looks like they're using possibly, I guess, Firefox maybe, Mac OS. So we see all kinds of stuff over here. AWS internal, Macintosh, Safari. Okay. There are 2 user agent values included in all log entries related to glitch user. Okay, so here's the command over here in description. This is the user agent string for the internal console used in AWS. It doesn't provide much information, so this is what that is. The second one here is talking about Macintosh, Mac OS, stuff like that, Safari stuff. This user agent string provides us with two pieces of interesting information. The anomalous account uses a Google Chrome browser within a Mac OS system. Interesting. Well, you can see Chrome here, then it says Safari after that. An experienced attacker can forge these values, but we should not dismiss this information. It can be valuable when comparing different log entries for the same user. We will park the current information for now. Let's gather more information to connect the dots. The next interesting event to look for is who created this anomalous user account. We will filter for all IAM related events, and this can be done using the select filter dot event source equal to inside of double quotes IAM dot Amazon AWS.com. Let's execute the command below and try to answer the following questions. What event names are included in the log entries? What user executed these events? What is the user's IP address? So let's go ahead and copy paste this over again, clear all this out. All right, let's take a look. Now, ideally, in the real world, as you're going through this process of investigation, you're going to take notes. Okay, so make sure to take notes before you clear everything out. That way you have everything in one place in case you need to reference those particular notes. But anyway, so let's take a look here. You got event type, event source, event name, user ID, or username, and source IP. So you can see McSkitty, and then here's the IP address here. All right, yeah, so there we go. Based on the results, there are many list policy events. By ignoring these events, it seems that the most significant IAM activity is about the user McSkitty invoking the create user action and consequently invoking the attach user policy action. The source IP where the requests were made is the 53.94.201.69. Remember that it is the same IP of the anomalous user glitch used. All right, so this is what they're talking about here. To ignore the list policy stuff and create login profile. You can see there, and it says attach user policy and create user down there. Yeah, so let's go ahead. Let's have a more detailed look at the event related to create user action by executing the following command. So let's go ahead and do that here. Clear. Okay, there we go. All right. Once again, of course, you're going to go through and review this JSON stuff. And let's see what they're saying here. Based on the request parameters of the output, it can be seen that it was the user McSkitty who created the anomalous account. Now we need to know what permissions the anomalous user has. It could be devastating. If it has access to our whole environment, we need to filter for the attach user policy event to uncover the permissions set for the newly created user. This event applies access policies to users, defining the extent of access to the account. Let's filter for the specific event by executing the command below. So let's go ahead and do that here. But yeah, as they were saying, you can see that McSkitty was doing all this stuff here. So username McSkitty, creation date. Yeah, create user. So there's the event name and everything. And then it says request parameters, username glitch. You can see everything here. Create a date, October 22nd, 2024. Interesting. So let's go to clear all this out. So there we go. All right, so let's see what they're talking about. It says McSkitty is baffled by these results. She knows that she did not create the anomalous user and did not assign the privileged access. She also doesn't recognize the IP address involved in the event and does not use a Mac OS. She only uses a Windows machine. All of this information is different to the typical IP address and machine used by McSkitty. So she wants to prove her innocence and ask to continue the investigation. All right, logs don't lie. McSkitty suggests looking closely at the IP address and operating system related to all of these anomalous events. Let's use the following command below to continue with the investigation. Okay, so let's go and do that here. All right. It sounds like their account probably got compromised or something like that. Maybe that's where this is leading to. But anyway, so this is what this brought up here. Oh, look at that. Mayor malware is back again. And then right away it goes into glitch. So you can see all that in. Then console login, mayor malware again. Looks like this happened all around the same time frames, as you can see there. All right, so things are getting pretty interesting here. Getting very, very interesting here. Look at that. Okay, let's see what they're talking about here. There's more logins down here about mayor malware. Based on the command output, 3 user accounts, McSkitty, Glitch, and Mayor malware were accessed from the same IP address. The next step is to check each user and see if they always work from the IP. Let's focus on each user and see if they always work from the IP. Enter the command below and replace the placeholder with the username. Okay, so let's go ahead and do this here. Clear all this out. And we need to replace the username placeholder, right? So let's go ahead and do that. And let's see. So let's check Mayor malware. So there we go. There's that information there. And also to make this a lot easier, instead of doing it that way, let's see. Okay, there we go. You can open up like a notepad type of application, right, and just plug that information in there. Makes it a lot easier to copy and paste. So we had the other one was glitch, and then McSkitty. So it's glitch, then copy and paste again. Okay, and replace glitch with McSkitty. All right, so let's go ahead and take a look at glitch's stuff here. Okay, and then the last one that I had open here. Let's see. Where is that? Oh, there we go. All right. For some reason, this is not moved over for some reason. I'm not sure why that's messed up like that. But let's go back into the terminal. Looks like our machine's having a glitch apparently. But anyway, so that's how you see everything here using that command, right? So you can go through and review everything that they're talking about here. Okay, I'm pretty sure we're probably going to have to use this information to answer the questions when we get to that part. All right, so let's go ahead and flip back over. It says, while gathering the information for each user, we can focus our investigation on the following questions. Which IP does each user typically use to log into AWS? Which OS and browser does each user usually use? Are there any similarities or explicit differences between the IP addresses and the operating systems used? Just based on the results, we have proven that McSkitty used a different IP address before the unusual authentication was discovered. Moreover, all evidence seems to point towards another user after correlating the IP address and user agent used by each user. Who do you think it could be? McSkitty has processed all the investigation results and summarized them below. The incident starts with an anomalous login with the user account McSkitty from this IP. Shortly after the login, an anomalous user account glitch was created. Then the glitch user account was assigned administrator permissions. Escalating privileges. And says the glitch user account then accessed the S3 bucket named Wareville dash care for wares and replaced the Wareville bank account qr.png file with the new one. The IP address and user agent used to log into glitch, McSkitty, and Mayor malware accounts were the same. The user agent string and source IP of recurrent logins by the user account McSkitty are different. Okay. Define evidence. Or, sorry, definite evidence. McSkitty suggests gathering stronger proof that the person was behind this incident. Luckily, Warville Bank cooperated with us and provided their database logs from their Amazon Relational Database Service, RDS. They also mention that there are captured these are captured through their CloudWatch, which differs from the CloudTrail logs as they are not stored in JSON format. For now, let's look at the bank transactions stored in the following directory here, wherever logs rds.log file. Since these log entries are different from the logs we previously investigated. McSkitty provided some guidance on how to analyze them. According to her, we can use the following command to show all the bank transactions. Grep is a Unix command line utility used for searching strings within a file or input stream. So let's go ahead and copy and paste this over. I love grep. It's awesome. Let's go ahead and clear all this out and then paste this over. There we go. And there's a lot of stuff going on here by Mayor Malware, apparently. He was in here messing with a lot of stuff. From the command line, McSkitty explained that all insert queries from the RDS log pertain to who received the donations made by the townspeople. Given this, we can see in the output the two recipients of all donations made within the November 28th, 2024. Okay, and this is what we're talking about here. So you have insert into Webflow bank transactions, account number, account owner, amount, values here, and then you have the care for where's fund, and here's the amount right there. So there you go. As shown above, the care for wares fund received all the donations until it was changed to a different account at a specific time. Okay, and says the logs also reveal who received the donations afterwards, given the account owner's name. With all these findings, McSkitty confirmed the assumptions made during the investigation of the S3 bucket, since the sudden change in the bank details was reflected in the database logs. The timeline of events collected by McSkitty explains the connection of accounts conducted by the culprit. Awesome. So here's a table here that says timestamp, source, event. All right, and you can see they have the logs here, and then have the event, last donation received by the Care for Wares Fund, bank details update on the S3 bucket, and first donation received by Mayor Malware. All right, question time. So go through and try to answer these questions yourself, and then come back to the video, and we will go through it together. Let's go ahead and take a look at these questions here. What is the other activity made by the user glitch aside from the list object action? Now, if we go through, this pretty much follows the same steps we followed earlier, okay? And this is the particular query we're going to be using here to figure this information out. All right, so I'm going to enter, and we see event name here, list objects, and the other one in here is going to be this put object. That's the one we're looking for, okay? And next one says, what is the source IP related to the S3 bucket activities of the user glitch? And we already figured that out earlier, which was this 53.94. Yada 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 IP address. So there's that one. The next one says, based on the event source field, what AWS service generates the console login event? Well, we are going to have to use a different query, so minimize that, and I have this in my notes here. So I'm going to go ahead and drag this one over here, where we're going to be querying for that information. Clear all this out, like so, and then plug this in. Like I said, this is all everything that we had looked at throughout this entire room, all right? But anyway, so you can go down this event source here, and you can see the sign in AWS console login over here for event name. So that is what we are going to be looking for. Sign in .amazonaws.com. Okay. Next one says, when did the anomalous user trigger the console login event? So as we see again, event name, constant or console login, and you can see that this is the time here, 11:28, etc., etc. So that's the answer for that one. And this is what was the name of the user that was created by the McSkitty user. Well, we already know that from going through the room, and that's going to be glitch. But if you want to try to figure it out yourself, you can go back in and try this here. So we're looking for this event name, create user, right? So go ahead and clear all this out, paste this in, and you can see here in the JSON, here's the user that's going to be creating the new user. So username McSkitty, and the user that they are creating here is going to be glitch. You can see that down there. All right, next one. It says what type of access was assigned to the anomalous user. All right, so to do that one, we'll have to take a look at the what it said for that policy. Yeah, attach user policy. Okay, so I'm gonna go ahead and copy this over, clear this out. Okay, paste this in, And then if we go through and review this, you can see that the policy RN here is going to be this here. Policy is going to be, or the access is going to be administrator access here. So that's what they're getting, right? So you're attaching that user policy to them. And that's the answer to that one, administrator access. Which IP address does malware typically use to log into AWS? Well, we already know that's going to be that 53 IP address, right? So that's the one in question. But if you wanted to look this up again, um, you can go and use what they were talking about earlier, where you go in and replace that placeholder, plug in that username you want to specify to look for information about. So let's go ahead and do that here. And this was towards the end of the lesson. All right, so it's going to go through and you review the information here, and then you can see the IP address is right there. Okay, looks a little bit kind of messy here, but let's go ahead and continue on. It says, what is McSkitty's actual IP address? Same thing here. You're going to use the same query, except you're going to replace Mayor malware with McSkitty, right? So let's go down here. Let's go ahead and grab it like so. See, and this is why you should take notes so you can reference everything easily in case you need to answer these questions. And you can see down here that, remember, 1128 is when everything went haywire and went crazy. So you see 1122, sign in, console login, McSkitty, and they said McSkitty uses the Windows operating system. So this is going to be what we're looking for here, this IP address. Okay, that's the real one. And it says, what is the bank account number owned by Mayor malware? And for this one, remember, we can use that grep command on that RDS log file, right? So there we have it right here. So we're going to grab that, go back over to our terminal and paste this in, review the information, and you can see down here, you see Mayor malware, okay? And then here is the bank account number information, okay? It's just following in this information here as it specifies bank transactions, and it says account number, okay? That's the first one, which is going to be this here, okay? And the account owner is going to be here, the second one, and then the value or the amount, okay? And this is the amount they put in there. So he's straight up robbing these people, all right? And that is pretty much it. It says, want to learn more about log analysis and how to interpret logs from different sources? Check out the Log Universe room. So check that out if you're interested in learning more about it. And that completes this particular task here. I really like this task. Like I said, the bread and butter for me, most of my experience comes from the blue team side of things. So instant response, doing internal SOC stuff, things in that nature, right? I love it. I love the thrill of hunting down this activity, doing some Batman detective work. Um, you know, sometimes you got to be like Sherlock Holmes to try to use deductive reasoning to figure out what's going on and what occurred throughout the entire situation, investigation, incident, event, whatever you want to call it. But anyway, I really like this because it referenced AWS, and I am not in AWS a lot, so this was very, very helpful for me in case I need to investigate activity in AWS. I know where to look now. I know what information to look for, how to apply particular queries, what to use for these queries, etc., etc. Hopefully, y'all enjoyed this task as well. This is probably one of the best ones I've seen throughout this event so far, honestly. But if you are new here, hit that subscribe button with the notification bell so you know every time I post something, upload a new video. Hit the like button if you're enjoying the content. Comment below your thoughts and opinions on the entire event, entire section, task, what have you. As always, thank you all for taking time to watch the video. Have a nice day, and I will see you in the next one.